Algebraic expressions. Constants and variables. A symbol having a fixed numerical value is called a constant. For example, 4, 6, 8 and -2. A symbol not having a fixed numerical value is called a variable, denoted by small letters. For example, A, X, C and Y. Algebraic expression. An algebraic expression is a combination of constants and variables connected by some or all the signs of operators like plus, minus, multiplication and division. For example, a plus 9 and ax minus 8, where a is the variable and 9 is the constant, combined with a plus sign. Terms of an algebraic expression. The parts of algebraic expressions are connected by plus or minus signs. Each part along with its sign is called the term of the algebraic expression. For example, 5x minus 3y is an algebraic expression. 5x and minus 3y are the terms of this expression. Coefficient. The term of the expression is a product of the numerical factor and a variable factor. For example, 5x and minus 3y. In 5x, 5 is the coefficient of x, and in minus 3y, minus 3 is the coefficient of y. Operations on algebraic expressions. First, addition and subtraction of algebraic expressions can be done only on like terms. Example, 5x will be added or subtracted with 3x. This is a like term. Second, multiplication of two or more algebraic expressions can be carried out. Third, division of an algebraic expression can be carried out. Factorization of an algebraic expression. Expressing an algebraic expression as the product of two or more expressions, then each expression is called the factor of the given algebraic expression. For example, a square minus b square is equal to a plus b, a minus b. Therefore, a plus b and a minus b are the factors of a square minus b square. To find the factors, there are a few ways, which are a. By taking out the common factors. For example, factorize 6x plus 18y. Solution. Here, 6 is the common factor for both the terms. Therefore, 6x plus 18y is equal to 6 into x plus 3y. Therefore, 6 and x plus 3y are the factors of 6x plus 18y. B. By grouping. For example, factorize ax plus by plus bx plus ay. Solution. Ax plus by plus bx plus ay is equal to, here we are rearranging terms, ax plus bx plus ay plus by. Now we can take x common from the first two terms and y from the third and fourth terms, which is equal to x into a plus b plus y into a plus b. Here we can take a plus b as common, and so a plus b into x plus y. Therefore, a plus b and x plus y are the factors of ax plus by plus bx plus ay. C. Factors of difference of two squares. A square minus b square is equal to a plus b, a minus b. Therefore, a plus b and a minus b are the factors of a square minus b square. D. Factors of sum and difference of two cubes. A cube plus b cube, which is equal to a plus b, a square minus ab plus b square. For example, 32x cube plus 108y cube, which is equal to, here we can take 4 as common, 4 into 8x cube plus 27y cube. We know that 8 is the cube of 2 and 27 is the cube of 3. Hence, 4 into 2x cube plus 3y cube. Now it is in the format a cube plus b cube. So we can write it as 4 into 2x plus 3y into 2x the whole square minus 2x into 3y plus 3y the whole square. We will simplify this. 4 into 2x plus 3y into 4x square minus 6xy plus 9y square. B. A cube minus b cube, which is equal to a minus b, a square plus ab plus b square. For example, 125x cube minus 8y cube. We know that 125 is the cube of 5 and 8 is the cube of 2. So we can write the equation 5x the whole cube minus 2y the whole cube. Now it is in the a cube minus b cube format, which is equal to 5x minus 2y into 5x the whole square plus 5x into 2y plus 2y the whole square. We can simplify this. 5x minus 2y into 25x square plus 10xy plus 4y square. E. Factorization of a quadratic trinomial of the form ax square plus bx plus c. For example, step 1. Factorize 6x square plus 13x plus 6. Then a is equal to 6, b is equal to 13 and c is equal to 6. Here b is the algebraic sum, c is the product if a is equal to 1, else ac is the product. Step 2. Find the product of a and c. In this example, a is not 1, thus we consider ac as a product. That is, AC is equal to 6 into 6, which is equal to 36. Step 3. Find two factors of the product AC. That is, 13x is equal to 9x plus 4x, such that the algebraic sum is B. That is, 9 into 4 is equal to 36. Step 4. Suppose the two factors are P and Q. Express Bx as Px plus Qx. That is 6x square plus 9x plus 4x plus 6. We can take 3x common from the first two terms and 2 common from the third and fourth terms. Step 5. The given trinomial can be 3x into 2x plus 3 plus 2 into 2x plus 3. Taking 2x plus 3 common, expressed as ax square plus px plus qx plus c, which is equal to 2x plus 3 into 3x plus 2. F. Factorization of quadratic trinomial of the form ax square plus bxy plus cy square. For example, 2x square minus xy minus 3y square. We can also write xy as minus 3xy plus 2xy, which is equal to 2x square minus 3xy plus 2xy minus 3y square. Since 2x minus 3 is equal to minus 6, which is equal to 2x square plus 2xy minus 3xy minus 3y square. Since minus 3 into 2 is minus 6, which is equal to 2x into x plus y minus 3y into x plus y. Since minus 3 plus 2 is equal to minus 1, which is equal to x plus y into 2x minus 3y. G. Factors of algebraic expressions reducible to quadratic trinomials. There are some algebraic expressions which are not quadratic but can be expressed in the form ax square plus bx plus c. For example, x raised to 4 minus 2x square minus 35y raised to 4. Taking x square is equal to a and y square is equal to b, we get x raised to 4, which is x raised to 4 is equal to a square, y raised to 4 is equal to b square, and x square y square is ab. x raised to 4 minus 2x square y square minus 35y raised to 4 is equal to a square minus 2ab minus 35b square. In the next step, we will write minus 2ab as minus 7ab plus 5ab equal to a square minus 7ab plus 5ab minus 35b square equal to a into a minus 7b plus 5b into a minus 7b, which is equal to a minus 7b into a plus 5b. Resubstituting the values of x and y, x raised to 4 minus 2x square y square minus 35y raised to 4 is equal to x square minus 7y square into x square plus 5y square. H. Factorization of an expression of the form a cube plus b cube plus c cube minus 3abc. Formula: a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus I. Factors of an expression of the form a cube plus b cube plus c cube. We know that a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. Case 1. If a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. Case 2. If a plus b plus c is not equal to 0 and a cube plus b cube plus c cube minus 3ab is equal to 0, then a is equal to b is equal to c. Polynomials. Definition: an algebraic expression of the form a0 plus a1x plus a2x2 till an-1 nx-1 plus an where a0, a1, a2 till an are real numbers. N is a non-negative integer, that is w, which is a whole number. It is denoted as p of x. a0, a1x, a2x till an(xn) are the terms of the polynomial. a0, a1, a2 till an are the coefficients of the power of x. Degree of a polynomial in one variable. Variable with the highest power in the polynomial is called the degree of the polynomial. For example, 7x raised to 8 minus 4x cube plus 1. Degree is 8. Degree of a polynomial in more than one variable. If a polynomial has more than one variable, the sum of the powers of the variables in each term is taken and the highest sum so obtained is the degree of the polynomial. For example, x cube y plus 4x cube y square plus 13x minus 7 is a polynomial in two variables. The degree of the polynomial is 5. Standard form of a polynomial. If the terms of the polynomial p of x are either in the ascending powers of x or in the descending powers of x, then such a form is called as the standard form of a polynomial. Ascending order: a0 plus a1x plus a2x2 till an(xn), and the descending order an(xn) plus an-1 xn-1 till a1x plus a0. Operations on polynomials. A. Addition and subtraction of polynomials. The method of addition and subtraction of polynomials is similar to the addition and subtraction of algebraic expressions. B. Multiplication of polynomials. Product of two polynomials is obtained just as the product of two algebraic expressions. C. Division of polynomials. Suppose p of x and q of x are two polynomials, such that q of x is not equal to 0 and degree of q of x is less than the degree of p of x. Then, dividing p of x by q of x gives us two polynomials, r of x and s of x, such that p of x is equal to q of x into s of x plus r of x. Here, r of x is equal to 0 or degree of r of x is less than the degree of q of x. The polynomial p of x is called the dividend, q of x the divisor, s of x the coefficient and r of x the remainder. Therefore, dividend is equal to divisor into quotient plus remainder. Coefficient form and index form of the polynomial. Let us consider the polynomial 5x cubed plus 4x plus 3x raised to 5 minus 7. Step 1. Given polynomial 5x cubed plus 4x plus 3x raised to 5 minus 7. Step 2. Write the polynomial in the descending order. 3x raised to 5 plus 5x cubed plus 4x minus 7 of the powers of the variable. Step 3. Add the missing terms. 3x raised to 5 plus 0x raised to 4 plus 5x cubed plus with coefficient 0, 0x square plus 4x minus 7. Step 4. Write the coefficient of each term separated by commas in a round bracket. 3, 0, 5, 0, 4 and minus 7. Step 5. Degree of the polynomial 5. Step 6. Number of terms in the polynomial 5 plus 1, which is 6.
Synthetic division. In the earlier part, we have seen how to divide a polynomial p of x by a polynomial q of x when q of x is not equal to 0. We now learn a method to divide a polynomial when the divisor is of the type x plus or minus a. Such division can be carried out by another method called synthetic division. First, x cubed minus 4x square minus 2 plus 1 divided by x minus 3. Solution. The dividend is x cubed minus 4x square minus 2x plus 1. In the index form, we will rearrange the equation in the decreasing order of power of x. It is already in that format. Therefore, index form is equal to x cubed minus 4x square minus 2x plus 1. The coefficient form is equal to 1, minus 4, minus 2 and 1. Comparing the divisor x minus 3 with x minus a and a is equal to 3. Now we can perform synthetic division. Here 3 is the divisor. Quotient is coefficients of polynomial, that is 1, minus 4, minus 2 and 1. Carry down 1, that indicates the leading coefficient. Then multiply 3 with 1. Write 3 below minus 4. Now add minus 4 and 3 is minus 1. Minus 1 multiplies with 3 and write minus 3 below minus 2. Add minus 3 and minus 2. It becomes minus 5. Now multiply minus 5 with 3. It becomes minus 15. Write it below 1 and then add 1 and minus 15. It becomes minus 14. Therefore, the quotient in the coefficient form is 1, minus 1 and minus 5. Therefore, quotient is x square minus x minus 5. And the remainder is minus 14. Therefore, x cubed minus 4x square minus 2x plus 1 is equal to x minus 3, x square minus x minus 5 minus 14.
Value of the polynomial. If p of x is a polynomial in x, then the value of the polynomial for x is equal to a is written as p of a,
and is obtained by putting the value of x as a in the given polynomial. For example, x squared plus 2x plus 5 when x is equal to 0. Solution: p of x is equal to x cubed plus 2x plus 5. Let's put x is equal to 0 in equation. Therefore, p of 0 is equal to 0 into 2 plus 2 into 0 plus 5, which is equal to 5. Therefore, the value of the polynomial when x is 0 is 5. Zeros of the polynomial. If for a polynomial p of alpha is equal to 0, then alpha is called the zero of the polynomial p of x. Relation between 0 and coefficient of a linear polynomial. If p of x is equal to ax plus b, where a is not equal to 0 and a and b belong to R, then p of x is a linear polynomial. Now, p of x is equal to 0, which means ax plus b is equal to 0. Therefore, ax is equal to minus b and x is equal to minus b by a, where b is the constant term and a is the coefficient of x. Relation between zeros and coefficients of a quadratic polynomial. If alpha and beta are the zeros of the quadratic polynomial ax squared plus bx plus c, then we know that x minus alpha and x minus beta are the factors of the quadratic polynomial. Therefore, ax squared plus bx plus c is equal to k into x minus alpha and x minus beta, where k is the constant, which is equal to k into x squared minus alpha plus beta into x plus alpha beta, which is equal to kx squared minus k into alpha plus beta into x plus k alpha beta. Comparing coefficients, we get a is equal to k, b is equal to minus k alpha plus beta, and c is equal to k alpha beta. We need to find out the values for alpha plus beta and alpha beta. Therefore, alpha plus beta is equal to minus b by k, but value of k is equal to a. Therefore, alpha plus beta is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x squared. Alpha beta is equal to c by a, where c is the constant term of x and a is the coefficient of x. Remainder theorem. Let p of x be a polynomial of degree greater than or equal to 1 and let a be any real number. If p of x is divided by the polynomial x minus a, then p of a is the remainder. For example, 3x squared plus x plus 7 is divided by x plus 2.
Solution: let p of x be 3x squared plus x plus 7 and the divisor be x plus 2.
Therefore, put x is equal to minus 2 in p of x. By the remainder theorem, remainder is equal to p of minus 2 is equal to 3 into minus 2 squared plus minus 2 plus 7, which is equal to 3 into 4 minus 2 plus 7, equal to 17. Therefore, the remainder is 17. Factor theorem. Let p of x be a polynomial of degree greater than or equal to 1 and let a be any real number. Then, x minus a is a factor of p of x if the remainder p of a is equal to 0. Conversely, if p of a is equal to 0, then x minus a is a factor of p of x. For example, x plus 2 is a factor of x squared minus 4. Solution: p of x is equal to x squared minus 4. Put x as minus 2 in p of x and we get p of minus 2 is equal to
minus 2 square minus 4, which is equal to 4 minus 4, which comes to 0. Therefore, P of minus 2 is equal to 0. Therefore, by the factor theorem, x plus 2 is a factor of x square minus 4.